Speak Student!
Secant angles a la Shmoop. Roger Goosebus has invented a new amphibious vehicle that he would like to test for navigational accuracy. To do this, he employed two of his new vehicle prototypes and a perfectly circular lake, located a few miles from his manufacturing headquarters. To test whether his vehicles are capable of traveling in exactly straight paths, Roger will have the vehicles take off on two routes that form an angle of 45 degrees. They'll reach the lake at 2 points, forming an arc of 60 degrees, and then they'll continue their respective paths across the lake, arriving somewhere on the opposite shore. If their journey is successful and the vehicles travel in perfectly straight lines, what should be the arc measure between them when they arrive on the far shore of the lake? Yeah, we don't make this stuff up. This is going to be a question you'll see in real life. The formula for finding any arc or angle measure involved in a secant angle problem such as this is secant angle K equals 1/2 the difference between the measurements of the far arc ABC and the near arc XYZ. With this formula, it's a simple matter of plugging in. The secant angle of 45 degrees equals 1/2 the difference between the measurement of the far arc, that's our unknown, and the near arc measurement of 60 degrees here. Multiply both sides of the equation by 2 to cancel out the half on the right side. 45 times 2 equals 90, so you get 90 degrees on the left side equals arc ABC minus 60 degrees. Add 60 degrees to both sides of the equation and we have the solution. Arc ABC should be 150 degrees if the experiment goes as intended. Now that all the theoretical measurements are in order, Roger's ready to begin the test. Perhaps he should have factored in a few more variables, like actual geese, for example. This has turned into a real honk fest. Hey, none of that foul language.